Hey friends, happy Wednesday. Today I was really tempted to just link a video to Khan Academy or link a video to a few other good math instructors, but I love this lesson. So here I am second guessing myself at 10:30 p.m. So I'm sure all of you are in bed and have been for a while. I want to go ahead and introduce this lesson because this is where we get the fun stuff. We are going to be adding some x's to our series. Oh, I'm so excited. And we are going to be creating some infinite polynomials in this chapter, and I'm so excited to do that. So here is my intro challenge to you, and I'm going to go ahead and I really want you guys to pause the video and see if you guys can get this for yourself. So here is my challenge to you. Here's my challenge. All right. I would like for you to construct a polynomial. So here's our polynomial of n. We've got a few coefficient. Well, this is our constant a sub 0. We have a coefficient there, and there. So this is a fourth degree polynomial. And I want you to create this polynomial with the following rules. These are the things that I want from it. First off, at 0, I want it to be 5. I want its first derivative at 0 to be 7. I want its second derivative at 0 to be 11. Third derivative to be 13. And then finally, your fourth derivative, I want it to be 17. So I want to create a polynomial where all of these things are true. So please, you should at least be able to get a sub 0. I promise you should at least get a sub 0 and probably a sub 1. But pause this video right now, please, and try to come up with something. What do these coefficients and constant need to be in order to satisfy these 5 things? So go ahead and pause the video and please try this by yourself. All right, so here's what I would like to see if you came up with it. All right, here we go. All right, first off, I have p of n is equal to a0 plus a1 of times x plus a sub 2 times x squared plus a sub 3 times x cubed plus a4 x fourth. All right, so let's go ahead and start with the easiest part right here. We have p of 0 equals, well, I want p of 0 to be equal to 5. So that means that this constant has to be 5. Actually, I'm going to cheat a little bit. This is going to be 0. I know that this is going to have to be 5. And then everything else, since I am substituting in 0, that's 0, that's 0, that's 0, that's 0. That is why that has to be 5. Cool. We've got our first portion. Yeehaw. All right, let's move on to the next. All right, so p prime of n is going to be equal to, well, if I were to take the first derivative of this, well, a1x will just be a sub 1. Now here we go, a2x squared, well, that will end up being 2 times a sub 2 times x plus, now the derivative of this is my constant, my derivative of this, I'll just bring that 3 out in front. So this will be 3a3 times x squared plus 4a4 x to the third. So do you see how I did all of those derivatives? First off, this is, if this were 5x, it would just be 5. 7x, it'd be 7, so on and so forth. All right, now looking at this, we can find another term here. I know that at my first derivative at 0, well, if I want this to be 0, or evaluated at 0, that will cancel out, that will cancel out, that will cancel out. And sure enough, heyo, I can find out another one of these. I want my first derivative at 0 to be 7. So I know that this has to be 7. We are on a roll. We are doing awesome. So my next one that I know, a1 has to be 7. All right, let's go another layer, and then I'm going to pause the video again. All right, so let's go ahead and take our second derivative here, our second derivative. All right, well, here we go. My derivative of 2a2x will just be 2a sub 2. All right, now I'm going to do something that's going to make some of you incredibly uncomfortable. I'm not going to multiply something. Chill out, you'll see why I'm doing it. All right, so I have 3a3x squared. Well, this 2 will come out in front. So I'll have 3. I know this is the part that's going to make you uncomfortable. You're just going to say it's 6. It's 6, Walton. I know it's 6. Calm down. There's a reason why I'm going to go ahead and leave it like that. So this will be 3 times 2x. All right, and the next one is going to be 4. Yet again, I'm going to go ahead and write it out because hopefully you're going to see why this is important. Times 3, this is a4, and that would then be x squared. All right, so all I did there was I took my derivatives. The derivative of a constant would go away. This is 2a2x, so that's just 2a sub 2. This one, my squared would come out in front. Yes, I know 3 times 2 is 6, but I'm going to go ahead and write it out like that, so hopefully you're happy. And then finally over here we have 4a sub 4 x to the third. 3 comes out in front. Yes, I know 4 times 3 is 12, but I'm going to go ahead and leave it like that. And guess what, guys? We can figure out another one of our constants here. So here we go. So I'm evaluating this at 0. So let's go ahead and talk about what cancels out here. If I substitute in a 0 here, well, I have an x there, so that whole term will cancel out. I have an x there, that entire term will cancel out. Now, here's where things kind of get a little bit fun. I know that I want this to be equal to, what I say, 11. It's kind of a random number, but okay. We'll go with 11. All right, and this is 2a2. All right, and so then I'm going to go ahead and divide by 2 here. All right, and I'm going to do another thing that makes you guys uncomfortable. I'm going to leave this as an improper fraction, 11 over 2. So up here, oh boy, I feel like I want to do this in a different color. We'll do it in red. Why'd I write that in blue? Silly me. All right, I have 11 over 2. All right, 11 over 2. So here's what I'd like for you guys to do right now, and I wish I had some elevator music for you. But following this pattern, what I would like for you guys to do is to figure out what is my A3 going to be and what is my A4 going to be. So please pause the video, try to find out what those coefficients are, and pause. All right, the moment that you've been waiting for or not. So here we go. Here's what I ended up with. All right, so A0 was 5, A1 was 7, A2 was 11 over 2. This one I ended up with, yes, I did not simplify it because we're going to start looking for patterns here. 13 divided by 3 times 2. The next one is going to be 17 divided by 4 times 3 times 2, technically times 1. Now you guys might be thinking, wait a second, Walton, this looks like something. Guys, my constant term was 5. Cool. My first term had a constant or a coefficient of the first derivative. Technically here, could I divide by 1? Yes. All right. For my second term, my coefficient, well, 11 is my second derivative, but then I divided by 2. My coefficient for my third term, 13 is the third derivative, divided by 3 times 2, technically times 1. And here we go, last one, my fourth coefficient is going to be my fourth derivative divided by 4 times 3 times 2 times 1. Guys, there's a pattern here. We could have done this from the very, very, very beginning. So let's go ahead and talk about what this means. All right, so if I want a polynomial approximation, my first term is just going to be my constant. All right, cool, f of 0. My second term is going to be my first derivative at 0 times x. Cool. My next term will be the second derivative at 0 times x squared. But what did we divide by here? This one we divided by 2 factorial. Ooh, all right, here we go. Next one, 1, 2, 3. I'm looking at my third derivative. I'm dividing by 3 factorial, x cubed. My next term would be f. Okay, I guess I probably didn't need to write all 4 of them, but here we go. Divided by 4 factorial, x to the 4th, and then finally so on and so forth. And what this has created, this is our polynomial of our own making that has everything that we are looking for. Now, here is what I would like for you guys to do for homework today. Here's what I would like for you guys to do for homework today. I want to talk about a function. I want to talk about sine. All right, here we go. So here's my sine of x. All right, ooh, look at that pretty. And as I'm looking at this, I'm thinking, this could be represented by a polynomial, correct? This could be represented by a polynomial. Looks like a polynomial, all right? It passes the vertical line test. We've got mins, maxes, zeros, everything's great. So here is what I would like for you guys to do. A few different things. First thing that I would like for you guys to find, I would like for you to find a fifth order polynomial approximation for sine of x. All right, and I want it centered at 0. Today we're just going to center everything at 0. I would like for you guys to find a sixth order polynomial approximation for cosine of x. And I want it to be, oops, get out of there, centered at 0. All right, and a few things that you're going to look for. First off, your book is going to be a huge resource, but in order to create a fifth order polynomial, you're going to need 5 derivatives. So start off, hey, you have f of x is going to be sine. All right, in order to use that formula that we just talked about, in order to use that formula, you're going to start taking derivatives. What's the derivative of sine? What's the second derivative, the third derivative, fourth? In order to do a fifth order polynomial approximation, you're going to need 5 derivatives. In order to do a sixth order polynomial approximation, you're going to have to do 6 ones. All right, so your homework for tonight is to figure out these two. There is going to be a Khan Academy posted, but you are not going to be required to finish that until tomorrow. So don't worry if that's a little bit too much. There'll be another video tomorrow, and then we should be all good. But these are your 2 homework assignments for tonight. And if you'd like to check in Desmos, you can. Oh, hey, that looks pretty good. Seems like it's a good start. All right, go ahead. I hope you have a wonderful Wednesday. Have a great day.